Hello and welcome back. We are in part 3 of section 2.4 and we're going to be talking about stem and leaf plots. Very simple idea, and hopefully you have your pre-printed notes in front of you. We're going to go through those and fill them out and no problemos. So talking about stem and leaf plots, it's a different way to display data, and the advantage of it is that it retains the actual data by showing it in graphical form. You can still see the distribution of the data and so on, but you have the actual data values in your display. What is a stem and leaf plot? So it's a data plot that uses part of the data value as a stem and part of the data value as the leaf to form classes or groups. And sometimes they'll tell you what the classes are, sometimes they won't, but it's very logical. So here's an outpatient testing center, and the number of cardiograms performed each day, and there's 20 of them, they're shown. It says to construct a leaf and data plot, stem and leaf plot for the data. Your first step is to arrange these in order. Now, you know, what I usually do though is I look for the minimum and I look for the maximum, and I will actually go ahead and put the stems in on the left hand side and then put the things on the right and then put them in order. But this is the way the book says to do it, so we're going to go ahead and go with the book this first time. So I arrange these in order. So you would go, okay, which one's the smallest? You'd put an X on it, and I have that's number 2. Then I look for something in the tens. So there's 14 and there's 13 and so on. So the order is 2, 13, 14, 20, 23, 25, and so on. So you can pause this and copy that down if you need to. Notice I also color-coded them because that's the way we're going to split them up in the stem and leaf plot. So it says separate the data according to the first digit. So they want you to group them together. This is also a step that I probably wouldn't do, but this is the step-by-step that the book gives you. So we're splitting up all this data. I just kind of spaced them apart. Now, it says a display can be made using the leading digit as the stem and the trailing digit as the leaf. Usually they do the tens. If you have a big data set, they do the tens as the leaf. So there's the stem rather, and then the leaf is the digit over here. So the tens place is the stem and the ones place will be the leaf. So you just see you have 0, 1, 2, 3, 4, and 5. So when you go to set it up, that's what you're going to have. So when you do your stem and leaf, they just do a vertical line down here, and then they do 0, and then they put the 2 over here. Then 1 would be our next set, and you'd have 3 and 4 to the right. And then 2 would be our next one, and you'd have 0, 3, and 5, because it's 20, 23, and 25. Hopefully you can tell the color coding here. So here's the 30s. So you'd have 3 to the left, and then the second digit, 1, 2, 2, 2, 2, 3, 6. And notice they wrote all of the digits. You write them all in there. It says in set notation, this is data. So you do write the repetitive ones over. They have their own place. 4 is 3, 4, 4, 5. So this is 43, 44, 44, 45. And then you have your 50. So that should be pretty easy peasy, right? Then you can kind of see how the data is distributed. Look how symmetric that is. You have a peak here at the 30s, and it's fairly symmetric. So when we go to analyze it, that's where the data peaks. You can find your minimum really easy, and you can find your maximum really easy just by looking at that distribution. So this stem and leaf shows that the distribution peaks in the center, and it has no gaps in the data. For 7 of the 20 days, patients receiving cardiograms was between 31 and 36. So that's because there were 7 data items here. 1, 2, 3, 4, 5, 6, 7. All right. And there was a minimum of 2 and a maximum of 57 patients in any given day. So that's kind of a neat way to display the data. So let's look at the next one. They actually tell you the classes to pick. Would I have picked these? Probably not. I like to go by tens, but since there's so much data here, they wanted you to split them by 5s basically. And when it says 50 to 54, they include 50 and they include 54. It's not, so if 54 is in there, it's included in the data in this class. So it says an insurance company conducted a survey on the number of car thefts. So this is how many cars were stolen in the 30 days. The raw data is shown. Construct a stem and leaf plot using these classes. Again, I color-coded them so that hopefully you can see how they break down. So the first step, arrange the data in order. This one might be a pretty good idea, although I probably would go ahead and put the 5, 6, 7, 5, 5, 6, 6, 7, 7, and just go through the data and put them in the plot to begin with, and then put it in order. I think that's a shorter way to do it. So pretend like you put it in order. You might want to pause the video while you copy the numbers, but there's what they are in order, and you can see how many green ones, blue, pink, purple, and so on. Now we're going to plot the data. Oh no, separate according to classes. So then they do this step where they put 50 to 54 here, 55 to 60 here, 60 to 64, and 65 to 70, and so on. Then you're ready to do the stem and leaf. Now, since you have 2 in the 50s, you're going to have 2 5s. So we're going to have a 5 for this part, 50 to 54, and we're going to have a 5 for this part. All right. Then you'd have a 6 and a 2 3. Then you'd have a 6 and a 5 5, 6 6, 7 7, so on, 7 8 9 9, and then a 7 and a 2 and a 3, and then the second 7s are there. So because they told us to use those classes, 5 5, 6 6, 7 7, you can now see that the data peaks right here in the center and that there's no gap. So there's a minimum of 50 thefts and a maximum of 79 thefts. So that's what you can tell just by looking at the stem and leaf plot. No gaps in the data, and the data is symmetric. More or less, it's pretty symmetric. All right, note, when the data values are in the hundreds, the stem is 32, so you still use the 10 spot there. So when we're doing the stem and leaf plot for some of these data values, we'll start with the hundreds. So we'll have 32 as our stem, 33 as our stem, 34 as our stem. So if we're doing these, you'd start with 32, 5, 7, 33, 0, 2, 5, 34 would be 1, 5, and 7. And if you have any trouble with this, please let me know. I can show you easy, because if it's not clicking yet, it'd be very easy for me to show you. All right, related distributions can be compared using back-to-back stem and leaf plots. The back-to-back stem and leaf plot uses the same digits for the stems in both distributions. Now, I had never actually seen these, but I think they're pretty interesting. And so this data is the number of the number of stories in 2 select cities. So the number of stories of buildings. So these are like Atlanta, 55 stories and so on. These are buildings in Atlanta and buildings in Philadelphia, and they're comparing the 2 cities. So arrange the data in order for both sets. And again, I would probably just go right to the stem and leaf plot, but here's the way I did it. And again, I'm using that color coding to kind of help you see where the different data is going to fall. So there's the order for Atlanta. And then if we put them in order, which I know you guys can do, so Atlanta's data set is here. We're going to do Philadelphia's here, that's on your sheet. So if we put those in order, you're going to have 25. There's your 30s, there's your 40s, 50s, 60s, and 70s. You can already kind of tell how the data is distributed just if you write it line by line. When you go to do the stem and leaf, they want Atlanta on this side, Philadelphia on this side. Since you still have the same amount, 2, 3, 4, 5, 6, 7 on these, you're going to have the same middle values. So normally you wouldn't have this side Atlanta, you just have this side. So we're going to start out, there's our first stems, and then you just put the data in that order. So Atlanta, it's 6, 8, and 9, but we go out from the middle. So the lowest value is here, 6, 8, 9. So we go from the middle out. Then the next set, and so on. So when you put those data in there, you've got those. And then Philadelphia will go in the order that you're used to. And you can see where the peaks are and if there's any gaps. Now, I don't think there was supposed to be a 70 here, so just erase that. If you put that on your paper, erase that 70 for Philadelphia. So when they want us to compare these distributions, you can see where it peaks and that there's no gaps in the data whatsoever. Which distribution has more variation? It's Atlanta. Where did the distributions peak? Both peaked in the 30 to 39 story class. That means that most of the buildings are in that category. Which class does Philadelphia have more buildings? In the 30 to 39 class. Which class does Atlanta have more? It's in the 40 or more story class. Are there any gaps in either distribution? No. And what type of technique do stem and leaf plots use? It's called exploratory data analysis. So that will complete your notes, and we will do some of these in class. Hope you have a good day. See you later.